Hello, everyone. Welcome to Virtual Cultivate 2020. My name is Daniel Norton. I'm the Senior Technical and R&D Manager for Horticulture here at Profile Products. Today, I want to share some Cultivate tech tips on managing substrate pH for chrysanthemums. So many of you that are on this webinar today are probably in the thick of chrysanthemum production. So it's definitely that time of year when everyone's thinking about fall mums. And this is just one of our customers that is growing in peat hydrofiber mixes. Actually, I believe this is 40% hydrofiber in this particular grower. And growers have been using hydrofiber since we introduced it to the North American market about 5 years ago. And they've had tremendous success. We've even had some growers that have trialed it in as high as 80% hydrofiber. And it worked very, very well. But today we wanted to discuss kind of a case study that we did, if you will, that occurred a couple years ago as we brought hydrofiber to the North American market. And as you can see in the image, we have a less than ideal situation that a grower was experiencing with hydrofiber in a core hydrofiber-based mix. And for those of you who may have sat on some of our other webinars or are familiar with hydrofiber itself, one of the things that we cover is chemical characteristics. And hydrofiber and the chemical characteristics that we put out in our literature has a pH of about 4.5. So it's acidic, somewhat similar to peat moss. That pH, on paper, you would think, okay, well, that's great. It has a similar pH to peat. I'm not really going to have to manage it too differently. And for the most part, that's true in peat hydrofiber-based mixes. However, when you go and combine hydrofiber with core, for example, that has a much higher starting pH, we began to see some very different situations. And again, this is an example of a grower who is growing several thousand mums. This is a very large trial that was being done. We saw early on that some very clear signs of chlorosis on the upper part of the plants. And just want to bring up some of the other symptoms that we saw. So this was intervenal chlorosis. It was primarily the newer leaves. We did some pH tests, and our pH was roughly about 7.3, so it was pretty high. However, the roots looked really nice and healthy, so that was a really good sign that we didn't have a soil-borne pathogen. So based on this data, we determined that this is an iron deficiency. Now, I did mention when I brought up the text box here in the previous text box that the roots look really nice and healthy. And I wanted to mention that because one of the things that a lot of growers will overlook when they diagnose these issues is the roots. And a lot of times they look at the tops, they say, okay, well, intervenal chlorosis, probably iron deficiency, which in most instances that would end up probably being correct. However, plants can manifest this issue if they have very poor rooting, which can either be the result of a root disease, or it could be due to overwatering, and so you just have very sluggish root performance. So if you are a grower that is either using hydrofiber currently or potentially looking to implement hydrofiber into your production, these are some things, key learnings that we've learned from this situation as well as some other scenarios. First of all, I mentioned that this was a core hydrofiber blend. Core has a pH of about 6, and even though hydrofiber has a pH of roughly 4.5, what we found through the university research is that the pH is very poorly buffered on hydrofiber. Whereas you contrast that with something like peat, which has a similar pH, it is much more highly buffered. So what that means is that hydrofiber requires a lot less lime to raise the pH of the substrate from 4.5 to 6, whereas peat requires a lot of lime relative to the amount of lime that the hydrofiber mix. So just to put that in perspective real quick, if we were to imagine a cubic yard of peat moss, it would require about 10 pounds per cubic yard of lime just to adjust that pH up from roughly 4.0 to 6.1. Contrast that with a cubic yard of hydrofiber. That cubic yard of hydrofiber would only take 1/4 of a pound per cubic yard of lime to raise that pH from 4.5 up to 6.1. So that really just is illustrative of the buffering capacity differences of peat and hydrofiber. And so again, when you take hydrofiber and you combine that with core, something that has very high pH, and then if you don't reduce the lime rate of that mix, then that's where you can run into these issues of having a pH that's over 7. Other mix types where you need to be aware of this particular issue would be like a peat or even a bark-based mix where you're using 50% hydrofiber, and that's because we've reduced the peat or the bark, which is providing a lot of the pH buffering in that substrate. That we want to make sure that we adjust our lime rate accordingly in those situations as well. Also, if you're a grower that has very high alkalinity and you're not acid injecting, or you're basically not properly treating that water with either acid injection or the right fertilizer source. So alkalinity, by definition, means either carbonates or bicarbonates that are in your water, and this is, more or less buffering of the water itself. And if you have high water alkalinity or high bicarbonates or carbonates in your water, that can actually increase your media pH over time if you're not careful. And so it's really important to do routine water testing on a regular basis. And then lastly, if this was a disease issue, or if this was an issue with overwatering, certainly take care to reduce the amount of irrigation. And we do have another series of webinars where we do spend a good bit of time on irrigation management, and we definitely encourage you to take a look at some of those resources because there are some differences when irrigating substrates containing hydrofiber. Let's do a very brief review on substrate chemistry. So on the right-hand side of the slide is an image that came out of a textbook that I have. And as you can see from the citation at the bottom, it comes from the early 80s. And, even though this is old data, it's really illustrative of what growers need to understand as it relates to soil chemistry. And basically what I have highlighted is in orange a range of 5.5 to 6.2 or 6.3. And in general, this is the target pH range that you would want to grow most crops in. Now, obviously, there's going to be exceptions. So some growers are, let's say they're growing blueberries, they'd like to keep their pH around 5 or even maybe lower. You may have some crops like geraniums and even mums where you want to keep it in the mid 6s. But again, in general, for most crops, this is true. And the reason for that is because this is the pH range where we have optimal availability of most of the nutrients in solution that are available to the plant. And as you can see here, iron becomes more available as we get to a more acidic pH. But whereas if we get to a pH of 7.3 that we had in the example previously, we see that iron availability becomes much less. And so this is very important to understand. So I mentioned here that many plants in general prefer a pH of roughly 5.5 to 6.2 or 6.3. However, in chrysanthemum production, many growers intentionally will grow their chrysanthemums at a pH of 6.5 or greater. In fact, a lot of growers prefer to target a target pH of 6.7 to 6.8. And the reason for this is to mitigate fusarium. So if you stay between that 6.5 to 7 window, roughly 6.8 target, you can help manage your fusarium. However, you may have your chrysanthemums may start to show some iron deficiency, And there could even be some more sensitive cultivars that are out there that may benefit from growing at a lower pH with regards to either phosphorus availability or even iron availability. So the challenge here in chrysanthemum production is how are you going to make sure that the plants have adequate iron while mitigating fusarium? So here's a couple of corrective actions that we would suggest, and these are pretty generic. And so, obviously it's going to depend on your particular situation. So certainly if you were to run into this issue, please reach out to one of your, or to your Hydrofiber technical representative, and we'd be glad to help out and walk you through the process. But in general, the first option would be to do an iron drench. So in this particular instance, A or B options, either iron EDTA or iron DTPA would be the preferable solutions for this particular situation. And the reason for that is because both of these chelated iron sources are going to be more available at higher pHs. Iron sulfate does work, but it's not going to be very effective at a high pH because most of the iron, or the iron in iron sulfate, is not chelated, and so it's basically not going to be readily available to the plant. Now, the advantage that iron sulfate has to the plant is that iron. Sorry. Okay, someone just came in. Sorry, I just heard this dinging sound. The advantage that iron sulfate has is that it can acidify the substrate. So if you're growing a crop like petunias, for example, and you want to lower the pH, then iron sulfate would be a good choice because it does have that additional advantage. You're not going to have that in the case of either options A or B with either chelated iron source. The other option would be substrate acidification. Again, in this particular instance, unless you're, really high pH, like 7.5, which a lot of times is really hard to achieve in soilless substrate production. But again, we have seen it happen before in substrates. You could switch to a fertilizer that has, higher rating for acidification, like 2177. The other option would be to do an acid drench. Those are very effective, but again, if you're in this particular situation like we had on the previous slide where the grower had a pH of 7.3, I would argue that an acid drench is probably going to do too much pH correction of the substrate and really overshoot the target pH of 6.8. So really in this situation, I would say that using an chelated iron drench would be ideal. So, but we should talk about what would be future ways to manage soil pH. Because we don't want to be putting ourselves into situations in the future where we know we're going to have to do subsequent either iron drenches or soil acidifications, because those corrective actions can be quite costly, and they can also cause a lot of headaches once you get into production. So, we highly recommend, taking the opportunity to take a step back, either during or after the crop cycle is completed, to reevaluate some of the, what kind of strategies could be done in your operation to mitigate this in the future. So first and foremost is proper lime selection. So one of the things that we spend a lot of time with growers on is helping them to select the right lime, and also to select the correct lime rate in the substrate. The dolomitic lime is most commonly used by most growers. However, we do see some growers that are using hydrated lime. One of the challenges with hydrated lime is that you can really overshoot your target pH very easily. And so it's very important that you understand these different lime sources and make sure to choose the right one for your situation. And again, one of the technical representatives from Hydrofiber would be more than happy to help you make a recommendation. Next, calibrations. So if you're making your own mixes, we highly recommend that you calibrate your mixing line at least once per year. We've seen several instances in the field where mixing lines have not been calibrated on a regular basis, and the lime hopper is dosing out the incorrect amount of lime. The peat hopper is dosing out the incorrect amount of peat. All these things influence the substrate pH. So it's not just the lime rate, but if you're adding more peat, for example, to the mixture than what you think you're adding, that also is having an acidifying effect on the overall mix itself. And so if you're incorporating an HPU into your mixing line, that's always a really good opportunity to come in and double check your peat calibration, your core calibrations, your bark, whatever you're using, as well as lime, and then be in the habit of doing that once per year. Reduce the lime rate. I'll get into this in a little bit, but general rule of thumb that we have based on the university research is that for peat hydrofiber mixes, you want to reduce the lime rate by 10% for every 10% peat that you remove and replace with hydrofiber. And core-based mixes, like we have in this particular example, it's a little bit more, it can be a little, require a little bit more thought through the process. But in general, if, you know, well, let me back up for a second here. In this particular example, we had a grower who was using core peat-based mixes, and their strategy was to eliminate peat and replace it with hydrofiber. And so in that particular example, that grower was had enough buffering in their water with their alkalinity that they were actually able to remove their lime out of the mix completely. Now that can be a challenge because you're more or less growing hydroponically. So again, this is one of those situations where, you know, we'd love to sit down and talk with you, look at your water quality, look at your overall mix strategy, and we can make some recommendations. I already talked about routine water quality checks. It's important to check your water at least once per year, if not once per quarter, would be highly recommended. If you're in the case of mums, doing a routine supplement of chelated iron in your fertilizer program is also a good idea. And then last but not least, it's always important to do routine testing so that you can catch these issues before they manifest themselves on a very large scale. And so just to kind of circle back with the, you know, this particular instance of this grower who had issues very early on, you know, when we met with the grower, when we noticed the issue, we took some of these corrective actions. In particular, we did drenches with chelated iron. We lowered the substrate pH with an acid drench and 2177. And as you can tell here, the two plants on the right-hand side had no issues finishing. They sold well, and the grower was very happy with this. I just want to spend a little bit of time talking about pH management and kind of walking you through a trial that we did with Dr. Ryan Dixon while he was at the University of New Hampshire back in 2017. This was a fantastic trial, and this is a point that I touched on a previous slide. And basically from the research that we got from University of New Hampshire, we came up with this rule of thumb that we recommend, and it really works very well, and it's really a good starting point for every grower. And basically when you take peat and you replace it with hydrofiber, for every 10% peat you remove and replace, you should look to reduce your lime rate by 10%. If you are replacing perlite with hydrofiber, which is where many of our growers start, it's actually really simple. Even though perlite typically has a pH of 6 or 7, and hydrofiber has a pH of 4.5, basically, both of these materials are virtually inert, which means they have virtually no buffering capacity at all. And so you can do a one-to-one substitution without changing your lime rate, period. Okay, so for those of you that are just looking to replace your perlite with hydrofiber, which is what many growers start out doing, you don't need to worry about changing your lime rate at all. However, when you start to replace peat moss with hydrofiber, that's where we look to reduce your lime rate by 10%. On this, that hydrofiber is less buffered compared to other raw materials. However, one of the things that is true and Sorry, the screen share just paused. Don't know what's going on here. All right. Sorry, it's still saying it's paused. All right, guys. I'm sorry. I've lost control of the screen share here. Okay, sorry about that. So, see, where did I leave off here? Okay, so one of the things that holds true for substrates with hydrofiber as well as conventional mixes is that even though hydrofiber is much less buffered than, let's say, peat moss, one of the things that has to be kept in mind is that the amount of lime in the substrate plays a much larger role in pH buffering than the actual raw materials do. So at the end of the day, when it comes to pH management in your substrate, the amount of lime that you put in there, the type of lime that you put in there is going to help play a much larger role in how well your mix is buffered. So that's something important to keep in mind. As we go up in the amount of hydrofiber, we will reduce the amount of lime required in the mix. That will also reduce the pH buffering of the substrate. And so we have some growers that are starting to look at, especially in poinsettias and mums, going to mixes of 50% peat with 50% hydrofiber. Those mixes have performed very well. But one of the challenges that can happen in long-term crops such as chrysanthemums or poinsettias is that because we have to reduce the lime rate roughly in half, that reduces the amount of pH buffering in order to maintain the pH of the substrate throughout the life of the crop in the greenhouse. And one of the challenges with mums as well as poinsettias is pH drop in the final, let's say, 3 to 4 weeks of production. So this can often be mitigated by changing your lime source or supplementing with a different type of lime. One of the things that we highly recommend is using a coarse lime, which will be less reactive in the substrate, but it will give you good longevity of your substrate pH so that you don't have to worry about pH drop-off. One of the things that we saw in this study is that the higher that you increase the hydrofiber amount in the substrate, the higher the risk of pH drop-off from the use of acidic fertilizers. So if you're a grower that commonly relies on something like 20-10-20, which is still pretty widely used, or they're using 21-7-7 on a routine basis to correct their pH because they're using the wrong lime rate to begin with, then if you're using 40 or even 50% hydrofiber, it's important to note that you do run a higher risk of lowering your pH significantly during production. And so that's where it's important to either use a coarse lime or make sure you do not reduce your lime rate too much. Otherwise, you can run into low pH situations if you're not careful. Now, conversely, we do not see the same issue, or at least not as big of an issue, with neutral or basic fertilizers. So a neutral feed being like a 17-4-17 or an alkaline feed like a 13-2-13. We do not see huge increases in substrate pH with the use of these fertilizers. And again, I just want to reiterate one more time, for every 10% peat in the substrate that we remove and replace with 10% hydrofiber, we highly recommend reducing the lime rate by 10%. And it's always important that anytime you make a lime rate change to your substrate, we highly recommend that you test this on a very small scale. So maybe do a bay, or if you can do an even smaller test plot, that's even better with these lime rate adjustments. Because one of the challenges, especially if you're going to reduce your lime, that you can run into is it can be harder to raise your pH in production. Whereas it's always easier to lower your pH in production through acidification of your water or your fertilizer, etc. So it's always important whenever you make a lime rate change, do it on a small scale, test it on a crop cycle, and then before rolling it out to your entire greenhouse. So let's just review some of the things that we've learned today. First and foremost, it's always important to diagnose correctly. If you don't have the right data, if you don't have the right information, it can make these situations difficult to diagnose and very challenging. For chrysanthemum production, we recommend keeping your pH around 6.8 and then supplement with iron as need be. Again, the reason why we recommend a higher pH range for chrysanthemum production is because it helps limit fusarium. It's important on a regular basis, if you're mixing your own soils, to calibrate your equipment. That way you make sure that you're dosing the right amount of peat, hydrofiber, core, bark, whatever, as well as your lime into the substrate. And then that way you know that you have the right amount of lime, and therefore you can be more, have a greater sense for the amount of, for your pH in your substrate. Make sure you use the right lime. So if you've been traditionally using hydrated lime or dolomitic lime or calcitic lime or a pulverized lime versus a quartz lime, make sure that you're using the right source for what you're doing. And the Hydrofiber technical team is there to help you make a good decision. And lastly, but not least, make sure to test, because testing on a regular basis in your crop is going to help you make better, more informed decisions, as well as take corrective action much sooner. And then lastly, again, for every 10% peat that you remove and replace with hydrofiber, you should look to reduce your lime rate by 10%. And last but not least, please do not be afraid to go high on your hydrofiber inclusion rate. Many growers all across the country have been very successful at 40 and even 50% hydrofiber. It's just important to understand what kind of adjustments you need to make in order to be successful. And I'd like to thank you all for joining me today. You can reach out to us with any questions that you may have at the number or the email address there. And thank you very much for joining us today.